In this video, we'll look at some more basic concepts to functions. And so the first one, which is quite common, is working out the axis of symmetry of a hyperbola. And so let's just say here's your equation. You'd very quickly just work out that your asymptotes are at what answer comes out of this bracket. For x, it would be positive 2. And the y asymptote would just be 4. So you've got those two. 5 is a positive on top, so just for your reference, it will be in the two diagonal, both positive, both negative quadrants. If you then ask to work out the axis symmetry, it's always going to have a gradient of 1 and always have a gradient of -1, and all that I need to do is sub in the asymptotes as a point. So in my picture, the asymptotes as a point would be 2, 4, and so this becomes a really easy, almost grade 9 question. I'm missing a letter, I just sub in a point, and that will give me the one asymptote that's going negative. It would be going there, and the other asymptote would be going there, but you can see that it will always go through the two asymptotes. So that's how you get the axis of symmetry. Then the parabola turning point is halfway between the two x-intercepts, and so two things. If I knew that these were the x-intercepts, and I got a complete blank and I forgot this formula for working out the x value at the turning point, I can just say it's halfway between. So this distance is 4, so halfway between that would be 2, so I must just go back 2 from 3, and I end up at 1. Thought differently, you could get a trick question where they do something like this. They give you either the whole turning point or even just the x value. Let me give you the whole one just for now. And they say find the other x-intercept. Then because the turning point is halfway, you would say to yourself, I've gone 2 back to get to the turning point, so I must just go 2 back from there. And that's how you could have got your other x-intercept. So just look out for the subtlety of moving backwards and forwards between them. If a point ever has a 0 in it, it's either x or y intercept. If you're needing a mixed fraction, you just go shift and the fraction button, and it will give you this mixed fraction. I've seen a lot of students that when they're trying to type in something like 5.5, they just type in 5 and then they go to the fraction button and type in half. But what your calculator is actually doing is it's going 5 times half, which is 2.5, as opposed to 5.5. So to be safe, whenever you see mixed fractions, just shift fraction button and punch it in from there. Much, much, much safer. The axis of symmetry for a parabola is literally just the x at the turning point. And so here, if I said to you, what is the axis of symmetry going through this parabola, it would just be x equals 1, because that's the x value there. It's not an asymptote, so I'm not drawing a dotted line because it's an asymptote. I'm just trying to show it to you. So for this example, the axis of symmetry would be simpler than what I did for the hyperbola. And then subtly, they may give you the a, b, c, q when they're actually writing out the equation. So please just look out for that. So you might have a big question for 20 marks that follows on from the very first one, and you were stuck because you thought this was still a plus ax squared plus bx plus c, but actually they had hinted to you by the way they wrote it that a is 1. And so look out for that. It really does make a big difference all the way to cubic functions in matric. I hope that you found this helpful. If you did, please like this video, subscribe to our channel, and share it with your friends.